you know, you could use a paper towel to get rid of.
Yeah.
What I generally do is make sure I cap this. And just make sure you clean, like, you know, any powder
Right.
like nearby. Of course, this might not be my mess, but you know, whatever.
Yeah, I always clean this back home, so I know the feeling of seeing mysterious white powder everywhere.
Exactly. Sometimes it's a peptide, sometimes it's tape, like it's really anything. And as for this, you could again use paper towel, unless you use something that's like hygroscopic, you know, that might contain like moisture or you know any of that sort. If you do like if you do manage to like get something that has like moisture and stuff on it, it's probably good to use ethanol or water to just clean it off and you know let it keep it dry. But since I just used like some powder which didn't really form in liquid, I could just place it back in.
Okay.
It's okay. Just make sure you properly wipe it down first.
Yeah, of course.
Okay. So we got the pack. And I could just write it down with a Sharpie. Sharpies, you'll be hunting all over to find Sharpies, like, but when you find one, the feeling is. So this is going to be our complete hydrogel solution. Because you know we don't really need enough. I mean, if you do get an aliquot, just make sure you label everything. But since we are dissolving the entirety of the solution in this, like the entire like hydrogel precursor, we could just so say I don't know, let's say maybe solution. Anything's okay. Like solution. So just make like marking, like you know, writing down and like labeling your tubes is like a good practice.
Yeah, of course.
If you end up forgetting like what aliquot you got, like that looks what, because everything is colorless basically. So you know, just put it back here once you're done. Okay. So I guess you'll find it like really easily. This is a -20.
Okay, this is the other -20.
Yeah, the synthesis phase.
Synthesis -20. Got it.
So we can find, there's a tube rack here. In general, you can find a lot of tube racks here. Okay. And then, so we have this ready. This one's especially powdery. I use this one. Let's take another one out. This one's less powdery. I don't know what. This one's always been powdery. I don't know why. Anyway. So we're going to need 3 syringes, right? Because we're making triplicates.
Okay.
So what I do is I just generally do this. So in order to, I can show you like once we make our gels, how we generally clean it. Just put them here. I mean, just sort of like keeping them around. So now we have, now we need 99.94 microliters of PBS, right? So for now you can use my PBS. It's marked with ARS. Those are my initials. So it's Duleco's positive synthesis. Celine.
PBS.
PBS, yeah.
Good old PBS.
Yeah. I think this is Ali's, you know, the other grad student. Like, so, you know, since it's like it's a non-sterile, you're not really using it with cells. You can just open it like outside. That's fine. But of course, as always, I mean, you can't just like open it and like there are things around or like you know there's like. Don't
contaminate it. Yeah.
I mean, those things sort of like impacted the gel in some way, and we're just trying to like. You know,
don't mess up what you can prevent.
Yeah, exactly. So these are generally either they look to me like they're 200s, P200s, and these look like they're P20s because they have their filter all the way to the end. So you could use this pipette, you know, this pipette rack. So this one is a P20. Goes up to 20 microliters. You can use it with this. Of course, there are just 2 tips in here for now, but you can sort of hunt around and find like tips in the main lab. Make sure you don't use the tips from the other. Don't use the ones from the synthesis room. Don't use the ones from molecular bio or TC.
Okay, so generally just don't carry stuff between them.
Yeah,
I don't need
don't
to.
carry stuff between them. Just don't like use one of the pipette tips. There are not any here. Maybe just ask around or just like improvise and use like a different.
Is there like a cabinet somewhere where you keep extra pipette tips around?
So we do have a cabinet for keeping pipette tips. It's generally like down there.
Down there, okay.
Yeah, it says pipette tips there.
Oh yeah, I see.
But
I see it.
I'm not sure if we sort of autoclave all of our tips and then use them. I think we do. Dorothy, do we generally autoclave all of the pipette tips before distributing the pipette boxes in every part of the lab?
We only autoclave when we use that for cell culture stuff.
Oh,
Yeah.
That makes sense.
yeah, makes sense. So, cool. So these are P20s, these are P200s. So we need 99.94, right? So this one goes from 20 to 200.
Sure,
Of course,
yeah.
you know that. So, and this one's one of the most annoying pipettes. I swear to God, because it doesn't have like the top. You know, you just gotta have to do this.
Oh yeah.
I'm just gonna go all the way down to 99. So it's 99.94, right? So I'm gonna try to bring it to 99.9. So this one is 99.8, right? This one, this division, 99.8 and then 100.
Mhm.
So I'm gonna bring it like right in between, make it like a approximate 99.9, you know. So, yeah. So I'm just gonna PBS. Alright,
Yeah.
that's it. So now past that, and now what we do is we just vortex it till we see like a completely clear. So this is where we vortex, and this is our microcentrifuge. You might need this because the PEG solution gets pretty viscous.
Mhm.
So you get some solutions on the side, and you sort of have to bring it down. So of course, make sure to use a balance as
Yeah.
well. Okay. You're pretty sure you know.
Yeah, yeah, yeah.
All this stuff, this sort of. And it sort of helps to do the other way too. Maybe I can use this one. Cool. So now we have our peg at the bottom.
Mhm.
Now the next thing we need is the crosslinker, right?
Mhm.
So I'm gonna get one of my aliquots. I'm hoping it still makes gels.
Sorry. Excuse me.
If it makes gels, just continue using this one because I've had problems in the past like trying to make gels, but I don't know if it was because of these aliquots or not. But if you see gels being made today, feel free to use these aliquots, okay?
Okay.
So, here. So you don't really need to label this because you know that it's spec-ductile. But generally the RGD or RDG aliquots are also in these microcentrifuge tubes.
Mhm.
So it's good to like label each one.
Yeah.
Because, you know, I can't imagine like, you know, my God, one time I spent like 3 hours trying to make gels because they were just not forming. I don't know what I did wrong, but I don't know. But anyway, okay. So you could just sort of like rub them around like this so that, you know,
Just trying to melt it.
yeah, the part out of there. And you need 8 microliters, right? So since our P20, this one's a little better. I can just do this. 8.064, right? Let me just quickly. Yep, 8.064. So what we generally do is we put the photo initiator at the end. It's very light sensitive, so the solution itself is sort of wrapped around it in this aluminum foil. So, you know, once we have everything ready in the solution, and we have like our syringes sort of like set up in front of the UV lamp, that's when we add the 12 microliters or like 10% LAP, and then we sort of centrifuge it. We vortex it, mix it nicely with like everything else, and then centrifuge it, and then we take 40, 40, 40 in the 3 of these.
Okay.
So that's like a rundown of the process. So this is 8. This is 8. 8.02, 04, 06. Yep, 06. I think that should be fine.
Yep.
0.06, because I can't get more precise than that. So it's gonna take some of this. Make sure, I mean, it's a good practice to not touch the solution, because the tip is essentially,
It's contaminated.
yeah, I mean, it's just more like, it's sort of like touch the entirety of the solution, so what you're dispensing from inside the pipette is exactly what you need, but it sort of mixes up with what's outside the pipette. You're not going to get like the precise volume, right? Accurate volume, sorry. Engineer stuff.
No, I gotcha.
Okay, so we got our pegdatile, and now we need LAP. It's our last step right now, so you can see how easy it is. We don't have to use RGD.
Mm-hmm.
I mean, even with RGD, it's just one extra step.
Right.
So
there's not really any like super time sensitive step. Okay, I worked with something kind of similar, but like as soon as you added the crosslinker, it just instantly solidified.
Oh, okay,
Yeah,
okay.
So that was the giving the last grad student I talked to trouble.
Yeah, I think it's that's the thing with like polymers, right? Like I think was that the last thing that you made was that like a sort of like a polymer, or was that like a hydrogel?
It was a hydrogel. It was a hydrogel.
Okay.
But it just really rapid cross-linking.
Interesting. Maybe it might not have been. Oh, so these are some of the chips. This is essentially that's the scale of like how small we want our hydrogel. Like,
Wow.
Yeah. So, I mean, if you can sort of make that happen, that'd be pretty awesome.
Mm-hmm.
But yeah, as usual, like let's see what ideas you come up with, and it'd be pretty cool.
Sure.
Okay. So it's on, and there seem to be. Put these out for now. Okay. So we need to add LAP to this. And I'm gonna. Oh, I also need the P20. Let's go get it. One sec.
The UV thing. Where's that?